I'm going to assume that this is working and saying it's recording. What's happening? Okay. All right. Should be working in theory. Okay, so last class we talked about our one-way repeated measures and ANOVA designs, right? These are pretty simple, no between group factors here. We're just looking at a set of repeated assessments over some interval, right? We talked about how these can have a natural order to them, as in we're talking about the inpatient data set where we have baseline, 2-week, 4-week, 6-week sort of symptom levels. And then we talked about that vignette study where we had a whole bunch of 8 different vignettes where we didn't have any sort of natural order, right? And in that study, I went through and counterbalanced all those vignettes. So there isn't even an order in which they were presented because they're all presented in scrambled order, right? And so we went through, talked about when we go through and test our omnibus effect, if we get an omnibus effect for a repeated measure, all that's saying is that the pattern of means across repeated assessments is different somewhere in there. We don't know where, it's just saying that repeated assessment, the mean of repeated assessment 1 is not equal to the mean of repeated assessment 2, repeated assessment 3, so on and so forth, right? And so we went through and took a look, remember in those analyses we had one, our ordered means had kind of a sort of a very clear reduction in symptoms. Our vignette study was kind of all over the place, right? So what we need to do now then is go through and figure out, okay, where are sort of the meaningful differences, or how do I want to approach this to start to break stuff down, right? Went through, talked about general approaches. This is just identical to what we had talked about before in our between group stuff, right? We have a priori tests that often involve paired contrasts or linear contrasts of some sort. And then we have a post hoc approach where we're just generally looking at all possible comparisons. The thing to remember now, so that gets dodgy in our straight between groups design, because depending on how many groups I have and how many factors, that can be a whole lot of stuff going on, particularly if I find interaction effects. Now with our mixed factor designs, if we have a between and a within, now all of a sudden, not only do we have all those different groups that we had with our between subjects design, now we have that repeated again and again and again and again and again, right? So with these designs, it's very, very important to have a plan for how you're going to go through and tackle this stuff, right? And hopefully that should be informed by, why did I set up the study? What are my research questions? Things along those lines. There's no one way to go through and tackle these designs. There's not a right way to run your follow-up tests. There are better ways than others, right? But if you just go through and decide like, oh, I'm going to look at all possible comparisons, you're going to have a goddamn mess on your hands, and it's going to be impossible to interpret what you have because you just ran through and done so many things. And if you go through and account for all of those, try to correct, you're going to have a massive correction that's going to swamp out anything but weird, inordinately large differences, right? So incredibly important that you sort of use theory, your conceptualization, to decide how I'm going to go through and approach this. Now, someone else might say, well, why didn't you look at this versus this? I don't know, there are means and standard deviations, knock yourself out, but these are the reasons I went through. These are the comparisons that are most important to me, okay? Now, some of this is going to be informed by the data, right? If I get an interaction and things that I want to test, like, don't all come up, but there's a clear, obvious difference somewhere in there, then you kind of follow that up, but that's treated more of an exploratory thing than a confirmatory, sort of based on my hypotheses, okay? So that's really probably the most difficult thing, is thinking about how I'm going to go through, tackle the follow-ups to start to pull apart some of these effects, okay? So we finished up last time talking about Benjamini-Hochberg. Again, this is nice because you can go through, and if you have a large set of effects that you're wanting to look at, you can just kind of order them all up here. It doesn't matter. We talked about like a modified Tukey, where we're kind of playing around with Tukey. to get an adjusted correction. It's not super precise, but it kind of, again, this is more like a horseshoe situation where we're just trying to put together some sort of reasonable approach to balancing multiple comparisons versus not wanting to undermine all of our power so that we just, anything we publish just wildly inflates effect sizes that we would expect. Okay. So, all right. So with our one-way design, last thing to go through and think about are how we're going to go through and calculate our effect sizes. Okay. Again, anytime we're doing means-based effects, sort of the thing that we need to be thinking about is what makes the most sense in selecting our standardizer. Okay. If I have just a one-way design, right? So in this case, I have 4 participants with 4 repeated assessments here, right? Go through, and if you're in the future, if you're going to go through and run through these designs, look at the stuff that I've got there and then jump into that Howell chapter. Howell does an amazing job of going through and pulling things apart, right? But one of the things that Howell recommends in terms of how do I go through and select a standardizer for a contrast, if there's a case where you have a baseline or multiple baselines, Howell will make an argument for using the standard deviation of means for the baseline scores as your standardizer. Okay, so let's say in this situation, my contrast is that repeated assessment A and B, these are both 2, let's say I've got a straight experimental study, A and B are both kind of baseline assessments, right? I have you do sort of baseline 1, baseline 2, and then maybe C and D are active manipulations or something along those lines, right? So if my contrast here was the comparison of the combination of A and B against D, what Howell recommends in terms of generating a standardizer for your effect size for this would be to look at the mean for the baseline assessments and taking the standard deviation of that. Okay, now, this is a little bit tricky to wrap your head around, but let's say that if I have, so here's my individual participants, here's my assessment scores across repeated assessments. Here on this column, this is just the average score across the repeated assessments for people. Okay, we seeing that? Okay, what Howell's recommending is like, well, if the contrast is A and B as compared to D, so like sort of your main manipulation, and A and B are kind of a baseline thing, what you might do is go through and calculate the mean for each person for A and B, and then take the standard deviation of that score, of those scores. So here in this situation, if I take the mean of A and B for participant 1 is going to be 3, the mean for A and B for participant 2 is 11, the mean for A and B for participant 3 is 25.5 and 30.5 for participant 4. Then what Howell is saying is like, okay, so that's my scores for my baseline scores. Then what I would do is take the standard deviation of those means that I calculated, right? So like really what you're doing is kind of generating a bespoke standardizer for this specific contrast, okay? And Howell's argument is that, well, if this is kind of your baseline, you're basically running like a version of Glass's delta here, right? Like talking about your effect as communicating the difference between the combination of A and B versus D as the increase or decrease in standard deviation units relative to average variability across your 2 baseline conditions. Okay. People kind of see how that's put together, and again, just shows you sort of some of the flexibility that you have in terms of thinking about, like, for that effect size, what do I want to use to standardize it, right? People kind of see, it's a little bit tricky, but people see how this is laid out, like where that's actually being calculated. Okay, so but this is kind of a specific case where I have like a multiple baseline design here. Other influential papers suggest, another thing that we can do is talk about the pooled standard deviation of cells included in the contrast, right? So for this one, we might take the pooled standard deviation of A, B, and D in terms of creating our standardizer. Now, with this one-way design, do we necessarily need to worry about our pooled formula? No, why not, Johnny?
Because you only have one.
Yeah, it's the same number. I can't have different cell sizes in this straight with one-way design because everybody's all the same, right? So again, though, remember the thing that I'll remind you here, remember that the pooled standard deviation, if you were to just take the standard deviation and pool that across these conditions, is not the same thing as the square root of the pooled variance, right? We're always working with variance, not standard deviations. Okay, so just watch out for that. Other thing we could do is look at the pooled standard deviation of all cells in the design, right? That would say our standardizer here, our formula stays the same. It's the value of our contrast or comparison over some standard deviation of error, right? I could go through and look at the pooled standard deviation of the whole design here, right? And just run that. That would also be sort of an option if I wanted to go that way, right? I kind of like this one better, right? The pooled variability and the contrast, just because like, hey, I'm just keeping this restricted to the actual assessments that are relevant to that comparison. But you could do, if there's no difference in, literally no difference in variability across these repeated assessments, you could just use the standard deviation, the whole overall thing, right? And that's the square root of your mean squared error, and that would just be fine too. So lots of different options. The thing that you need to do, and the thing that makes these difficult, is you need to know, one, what am I doing, and two, why? Like, why is this a better choice than something else? Or why can I argue for this versus that? Okay. Questions about options in terms of standardizing effect sizes for these one-way designs. Yeah.
So I'm a little bit confused. So for B, I get the example of like pooling A, B, and D. Would we see that in like the problem set, like which one you'd want us?
I will want you to think about like sort of what approach that you want to take and sort of give me a justification for that. Just like we did last semester.
So we would just like omit one that's not, okay.
Yeah.
That's clicking.
Yeah.
Okay.
Yeah.
Is the Howell approach only when there's multiple baselines, or like if A was a baseline, could you do like A versus D and then just calculate the standard deviation for A?
Yeah, I mean, it kind of, this is kind of getting back at a kind of a glasses delta type approach. Yeah, and so if A was your only baseline and B, C, and D are all active, then yeah, just use A as that's just your baseline.
Okay.
But if you have multiple baselines, right, then and maybe you want to make sure that we go through and account for it. And so the argument is that if I have A and B are both baselines and those are both in there, there's more data to work through a solid standard variance estimate with that versus just one assessment. Okay. Questions? You guys are awesome. All right. Now, if we want to go through and start thinking about getting confidence bounds around our repeated measures effects. Confidence bounds around eta squared, omega squared. For our repeated measures designs, I don't know, it gets tricky. There's mathematical stuff that works out, and this literature is consolidating, and SPSS is starting to include stuff in. So there's some stuff going on, but rarely are we. I used to have people do this, but at the end of the day, the effect size for your omnibus test is rarely something that people are super interested in. And so jumping through a bunch of hoops to calculate the upper and lower bound for your omnibus is probably not worth your time unless you're just like really hardcore on stuff. We do have confidence bounds for your paired sample T's and your contrasts. But this kind of, so we start to get restrictions on what we can choose as our standardizer for these effects, right? Remember that when we're going through calculating our confidence bounds for our effect sizes, this is based on our non-centrality parameter, right? That we got from our little Sager calculator. And in our paired sample t-test, the standardizer for our t-test is the standard deviation of difference scores, right? But, and so as a consequence, the confidence interval so we need to get a t-test to put in our NCP calculator in order to get upper and lower bounds for a non-centrality parameter, right? But the t-test that we're using to put in there is based on the standard deviation of the difference is my standardizer, right? And that we know is we have to be careful using the standard deviation of difference scores as my standardizer because I'm worried it's going to inflate effects, right? Because if I have, let's say, a situation, and this is a throwback to last semester, let's say time 1, time 2, and I've got 1, 2, 3, 400, right? And I see scores as 5, 70, 33, 25, 60, right? What's the variability of that? What's that?
Wouldn't it be large?
Yeah, it's huge, right? Huge variability. And at time 2, let's say I have 15, 80, 43, 35, 70. Variability at time 2, massive, right? But remember that my paired sample t-test, the only thing that I'm sort of concerned about, like this is all fine and good, but all I'm interested is I'm just running a single sample t on the difference scores, right? And my difference scores here are 10, 10, 10, 10, 10, right? So huge variability here, huge variability here, no variability here, right? This would become problematic for lots of reasons, right? But we can start to see how in a situation where the standard deviation of my difference score is going to be sometimes much smaller than the variability of time 1 to the variability of time 2. And so we have to be careful. If I were to use it, sometimes if you're using the standard deviation of your difference score as a standardizer, your effect size is going to look massive versus if you were using, say, like a Glasses delta or a pooled variance estimate, sort of across those, right? The problem is that if we're going through and going to calculate our by hand, the way we did it all by hand, if we're going to calculate a confidence bound around an effect size for a paired sample test, using our NCP calculator, we have to use the standard deviation of the difference. Otherwise, what's going to happen is you're going to get a confidence bound that doesn't actually contain your point estimate, which is problematic, right? So things have changed over the last semester now because SPSOs will provide you with this stuff sometimes for paired sample tests. You just want to be careful in thinking about what is, and also just be very specific about, like, know what SPSS is using as your standardizer and what the implications are for your tests and interpretation and things along those lines. Questions about this? Again, this is stuff that we talked about last semester, but just as a refresher as we go on stuff. Okay, cool. All right, so and do people have their slides up? Because it's probably hard to see on here, right? We had two tests, right? Or two analyses we ran. First one was our inpatient depression, right? And what we found is that there was evidence for changes in repeated assessment over time. And if we go through and take a look at what that looked like. Okay, well. Okay. Anyway, if you remember, we had sort of just basically sort of a big reduction in scores over time. So what we can do here in that situation is what we decided to do. And I guess, yeah, if you have and can pull up your one way. You have those handouts, the one-way repeated measures for ordered means and belief ratings. Right? If you open that PDF and just kind of take a look, just to refresh yourself in terms of what we saw there. So yeah, this is your one-way RM ANOVA for belief ratings and ordered means, right? We've just found something like this, right? We're just seeing a reduction in scores over time. And people remember what that effect looked like.
Is that from last semester?
What was that?
When was this? Was
This
it
is my
last?
last class.
Oh.
So with this, pretty simple. We've got no groups. We've just like measuring scores across a period of treatment here. Pretty standard, straightforward, right? Now, one thing we could do with something like this, we could go through and look at those polynomial contrasts, right? I could go through and say, yeah, I'm seeing evidence for differences in means across time. I could go up to my test of within subjects contrasts on that sheet and just take a look at my I could say if I go through and take a look at that, I've got evidence for a linear contrast that's massive, and then a quadratic. It suggests maybe a little bit of a curve. And then I've got a cubic that's coming up. That's not interpretable. There's no reason for me to assume that this is sort of a two things, but it's coming up, right? So you have to be a little bit careful with that. But what I could do is I could just look at that linear and say, yeah, I have evidence of linear reductions based on my polynomial contrast because they're ordered up and they're fine. Okay. But I could also go through and say, really what I'm interested in this analysis is, do I have evidence of pre to post treatment reductions? Okay. Do I really need to go through and run statistics on this? Not really. It's very huge and very obvious reductions, but probably if I'm going to go through and publish this, people are going to want to know, well, how much of a reduction, kind of magnitude, things like that. So a lot of times with these paired sample tests, like the focus is a lot of what we've been talking about all semester. It's not just like, is there a difference? It's how much of a difference there is, right? And so here, if we go through on this slide, what we've done is we've gone through and said, okay, to follow up on this one-way test, one-way omnibus, I'm just going to look at differences at from baseline to discharge here. Now I could go through and look at differences between intake and 2-week assessment, intake in 4-week, and intake in 6 weeks, and 2 and 4 and 2 and 6 and 4 and 6. Is that useful? Probably not. It's just a whole bunch of stuff. Just at this point, I'm just running comparisons to run comparisons, right? And if someone's like, well, you didn't look at the difference between 2 and 4-week assessment, I'm like, well, why? Like you tell me why that's an important thing to go through and look at, or something you can't just use the eyeballs in your head to tell me what you think is going on with this. So we're just going to go through and shorten this up. We're just going to say we're going to look at pre to post treatment reductions to go through and qualify this omnibus effect that we've had. So all I did here, and I'm just going to sort of keep it simple. I'm going to go through and I'm just going to run a paired sample test from baseline to 6-week follow-up. Okay, just run a paired sample T. I'm not even interested really in what that p-value is because it's going to be massive. It's a T statistic of 27.7, right? Like the p-value is superfluous here, really. But what it is going to go through and it's going to give me is a confidence bound that I can go through and talk about. And I can ask for an estimate of effect size down here at the bottom, right? For here, what I've requested, and this starts to become important, I've looked for the square root of the average variances for Cohen's D. And actually, if I'm thinking about this, is this maybe the best standardizer for this effect? I'm using the pooled variance from time one and time, or from baseline to post-treatment or discharge. What might be a better option in SPSS? Do I ever, what's that, Haley?
The triangle.
Yeah, the delta, I've got a nice baseline, right? I've got a standard baseline where everybody's coming in, right? So probably that might, I think I can select that. That might be a better option. I just kind of defaulted here, but that would arguably be a more meaningful metric for interpreting change. Because then I can say relative to variability at baseline, we're seeing an X standard deviation decrease in people sort of over the course of treatment. Right here, we're just saying sort of average variance at time one and time two, right? Now here that could be very different. And so I guess for clinical people, like thinking about variability when people come in, everybody's kind of in a bad place. And so you don't have a whole bunch of variability. At the final assessment point, do we see variability? Yeah, ton of variability. Some people improve, some people don't, everything in between, right? And so probably if I were to go through and ask for a glasses delta, I'd probably get a bigger effect size because what I'm using as my standardizer is going to be based on less variability than more, right? But you can go through, take a look, sort of play around, sort of think about like, oh, what makes the most sense for this, okay? So here, what we've done, went through, did that, and so this is all sort of, this is basically just for me to provide some context for what's happening. So we're saying follow-up analyses indicated average reduction of 17.8 points on the BDI, with population estimates ranging from 16.5 to 19.1, right? So to tell them, I think this is important for this context. And again, this is something that maybe clinical people should be thinking about. Basically, I'm saying, Danielle, if someone comes through my inpatient program, how much should I expect people to, how many points BDI points should I think people should produce? Well, my best guess is about 18, but based on my data, anything from 16.5 to 19 is going to be pretty good. Clinical people, like, is that a reasonable reduction in BDI? It's a pretty good, substantial reduction, right? So we're just talking about, this is a nice application because you can think about like, hey, here's what you can expect coming into my treatment program on average for reductions, right? We say responses to this study exceeded conventional benchmarks for large effects, with patients demonstrating nearly a 1.6 standard deviation change in scores over the course of intervention, right? That's a massive effect size, right? Then we're saying the lower bound estimate of the population effect in these data continue to support reductions in excess of 1.4 standard deviations. I'm going down through and taking a look, SPSS has calculated upper and lower bounds for my effect size here. If I look at the lower, and this is the upper bound because it's closer to 0, but the smaller bound on my effect size, it's still suggesting close to a 1.5 standard deviation reduction, right? So, hey, even if you want to take the most conservative approach based on the bounds that I've got, we're still seeing a massive reduction in scores here, right? Results offer substantial support for large and clinically significant change in global depression for individuals receiving inpatient. How do we like this in terms of an interpretation? I like it. I mean, I wrote it, so I'm clearly biased, right? But looking at sort of taking some of this information and kind of pulling it together, like, I don't care about p-values here. It's sort of beside the point. What I'm trying to do is communicate practical implications by looking at magnitude, effect sizes, things along those lines, right? Take this versus what we could see. Follow-up tests indicated significant reductions in overall depression. How do we like that? I mean, it's fine. It's kind of boring, right? Like, there's just so much more you can go through and talk about and actually like communicate cool stuff, right? Boo that, right? We just have so much more stuff to go through and talk about that we can go through and use and incorporate to qualify these effects than just saying that there's a significant reduction. Okay. All right. Questions about the repeated measures or the sort of the ordered effects. Okay. Now we get into this one, right? This is a little bit more tricky because here what we're looking at is ratings on this on these vignettes, right? And there is no order to these vignettes. These vignettes kind of bounce all over the place, right? So what I have to do is I have to start thinking about like, what is my primary goal? Why did I run this in the first place? Why is this interesting? Why did I run this study to start with? Okay. And so let's say for this, before I ran this, so remember we had 4 vignettes that were trauma focused stuff. I think we had a car accident, a sexual assault, a natural disaster, and something else. Maybe military, I think military trauma. And comparing that against partner infidelity, financial loss, job relocation, and chronic illness. Okay. Very, very, very stressful things, but not something we put under the trauma umbrella. Okay. And so maybe my hypothesis, the reason I had 4 big T trauma and 4 stressor events is to look at difference in people's willingness to provide support to people in sort of like big T trauma stuff versus other stuff, right? And so maybe my hypothesis here, I think that individuals are more willing to provide people support to like sort of non-trauma stressors than stressors, because trauma stressors, there's sort of the stigma associated with that, right? So it's things like assault, combat exposure, things along those lines, kind of associated with stigma, discrimination, and things like that. And my hypothesis is that what we should see is more willingness to offer support and friendship to people who are exposed to sort of non-trauma stressors versus trauma stressors. Okay. Now, all of a sudden, this clarifies how I might go about and pull this apart, right? Because I've got 8 of these, right? So if I have 8 times 8 over 2, 56 divided by 2, 36. What's 56 divided by 2? 20.
23.
23. There we go.
That's not right. Sorry.
Is that all right? 27.
Wait, what?
There we go.
28.
28. There we go. Yeah, glad we'll get it right eventually. Okay. There are 28 possible pairwise comparisons that we could sort of pull apart with this, right? That's a ridiculous number of pairwise comparisons to go through, right? And some of them are going to come up, some of them aren't, like trying to sort of tell a cohesive story. It's a mess, right? And then if I go through and I have to correct for 28 pairwise comparisons, my alpha level is going to be so incredibly small that only things that are wildly overestimated are going to come up, right? So this is a boring and not a good way to go through and do this. But if I go through and I say, the reason I've done this is, so my main focus for all of this is to try and look at the difference in how people respond to trauma versus non-trauma stressors, right? So now all of a sudden what I'm saying is my hypothesis is that people will be more willing to provide support to people with non-trauma stressors than to trauma stressors. Now all of a sudden I have a specific contrast that I can run, right? That's pretty cool because I can take all of this and just kind of reduce it down to running my contrast, right? And so the t-test for my contrast is just going to be the value of my contrast over the sum of my squared weights times the mean squared error for my overall ANOVA over the size of my sample. Okay. And that was in a previous slide that we can go back to. You go back through and take a look at. But down here, this is too small for you probably to see, but you can probably see it on your own screens. Here, value my contrast. I'm just going to go through and weight this. I've got 4 non-trauma vignettes, 4 trauma vignettes, right? To set the value of my weights, I just take the reciprocal of the number of groups on one side of the contrast. So I've got 1 divided by 4, right? So I just take 0.25 and 0.25. I've got 4 and 4, right? I just simplified this. I could take and then assign a negative weight. I think my trauma group is going to score lower than my non-trauma group. And so I assign a weight of negative 0.25. And then I'm just taking that, I could go negative 0.25 by this, by this, by this, by this, or I could just sum those up, and multiply the whole thing, just, people see I'm just reducing my, streamlining my math here. Okay, so here, go through, just weight, my, non-trauma, or my trauma means by negative 0.25, weight my non-trauma means by 0.25, go through, run through, and I get a, value of my contrast of negative 2.256. Okay. Do I have a standard set here? Remember, Darius, if we have a standard set, it's the sum of our weight, the absolute value of our contrast or our weights is equal to 2, right? So if I take 0.25 plus 0.25 plus 0.25 plus 2.5, 0.25 plus 0.25, 0.25, 0.25, 0.25, I get a value of 2, right? So I've got a standard set, which means that the value of my contrast here is specifically in terms of sort of the raw units that I'm using here, right? So can someone give me an interpretation of the value? So what does the value of this contrast mean? What is this giving me literally? John?
I think that there's a difference between the non-beams, the non, I forgot the thing,
Yeah,
the non versus the, what's the word I'm looking for?
The big T trauma versus the.
Yeah, well, or just like,
yeah,
lost my train of thought.
I got you. And you're exactly right. You're exactly, I see there, I just like sort of jumped into Gabe's brain. I know exactly what you're talking about. Yeah, this is just literally the difference in the average friendship rating
There,
for my non-trauma versus.
there you go,
trauma.
trauma.
For my trauma versus non-trauma vignettes. But it's negative. What's happening here? Yeah, it means that I'm actually seeing more willingness to provide for my trauma group than my non-trauma group, right? So now all of a sudden I've got something going in the opposite direction of what I had expected, right? So here I'm seeing the average for my trauma group is actually higher than for my non-trauma group. So this should alert me like I've got a sign change. It's flipped around in the wrong direction, right? But here's the value of my contrast. What I can do then is use this to go through and calculate a T statistic. So here's my value of my contrast divided by the square root of the sum of my weighted means, or the sum of my squared weights. So I've got 1/4 squared times 4. And again, I'm just reducing my math here, right? Plus negative 1/4 squared times 4, because I got 4 of those, right? Times 0.766. Where did I get that? You go back through your test of within subjects effects, look at your mean squared error from your overall ANOVA table. That's where your error term is. Drop that in there, 231 people in the sample. I go through, run that, and I get a T statistic of negative 6.24. And then my degrees of freedom I'm comparing against 1177. Where did I get that number?
Which number did you say?
This 1177 for my degrees of freedom. Yeah, exactly right. Olivia, what is that?
Your error degrees of freedom.
Yeah, my error degrees of freedom. If you go through and you take a look, so the same column, I got my mean squared error. If I look at the degrees of freedom associated with that mean squared error, it's 1177.905. You can say, oh, I'm gonna round that up to 1177 or 1178, but I don't know. It's giving me more degrees of freedom than I have, so I just kept it 1177. It makes 0 difference in this case because the number's so massive, but just being more conservative, not giving myself more degrees of freedom than unnecessarily warranted, okay? And so is a T statistic of that size with that degree of freedom, is that gonna come up as meeting criteria for interpretation? Yeah, it's gonna be associated with a massively small p value there, okay? So went through, did those calculations. Then over here, what I wanna do is I wanna go through, calculate my effect size. Oh, and then I got an S value, Bayes factor, with that. Then also wanna get an effect size for this, right? So here, what I'm taking, this is supposed to be my variance, my average variance across here, right? So I'm taking my standard deviation estimates that aren't listed up here, but I pulled those from the descriptives, right? Here are my standard deviation estimates squared for everybody, divided by the fact that I have 8. Do I have to worry about pooling anything with this? No, because everybody it's the same number of people across the board. I could plug this into our pooled variance sort of formula, but it's gonna give me the same thing, okay? So I go through, get that, I get a variance estimate of a pooled variance estimate of 1.106. Take the square root of that, right? Because remember, we want to get to the pooled standard deviation. We have to go through, start with variance and then take the square root of that to get your pooled. If I were to just take the pooled standard deviation, I'm gonna get a different number than that, okay? So go through, do that, then take the value of my contrast divided by my standard deviation, and I get an effect size of about 0.24. People see how I went through and sort of got those values in these hand calculations here. Any questions on sort of any of my decisions or why I decided? Here, is there a good baseline in this scenario where I could like, oh boy, glasses delta would be really the place to go with this? No, right? There's nothing to say that my trauma versus my non-trauma group should be a baseline for anything. And so just going through and taking the square root of the average variance across these groups is going to be probably my best bet for this. So pulling all this together, right? What I'm going to say is planned contrast, comparing willingness to maintain friendship, hypothetical individuals exposed to either traumatic or non-traumatic events, offered compelling support for incremental differences across event type, but in the opposite direction of what I had hypothesized, right? And then here's my T, my P, my F, my Bayes factor, my effect size here, right? Results found that participants indicated a 0.256 unit reduction in willingness to maintain friendship with when presented with vignettes involving individuals exposed to non-traumatic versus traumatic events. Again, throwing my mean values in here so you can literally see kind of what that difference looks like. Lower bound estimate for population difference indicated a 0.18 unit reduction in upper bound, supporting a 0.34 unit decrease in willingness to maintain support. So just kind of going through, talking about my confidence bound here. I didn't include that here, but if you've got your point estimate, you've got a standard error estimate, then calculating your confidence bound is pretty straightforward, right? It just, whatever your T value for alpha 0.05 with 1177 degrees of freedom, you're just going through and generating a confidence bound for that. Okay. Effect size from the point estimate of this discrepancy was small, suggesting about a 4 standard deviation reduction in willingness of ratingness to maintain friendship. Results provide strong evidence for incremental reductions in willingness to provide support for hypothetical survivors of non-traumatic versus traumatic events, although this effect was not predicted in the initial hypothesis. Again, saying like this is in the opposite direction of what we had expected, right? We're trying to make that clear. Also not clear the extent to which such an effect might, or the extent to which such an effect may result in an observable impact on behavior, right? Because it's pretty small, right? In terms of friendship ratings, a lower bound of about 0.2 of a unit doesn't seem like much of an impact, right? But thinking more globally or interpreting within the context of what we did, it's important to note that the methodological approach used in the study holds a strong potential for socially desirable responding. You know, we're just asking randos if they could read this and be like, hey, tell me how much you'd be willing to go through and to support this person, right? It's really kind of, and if you look at these data, remember, it's all very negatively skewed. Most people are saying like, yeah, sure, reporting high level, because it's no cost to me, I don't wanna look like a jerk, right? So I'm like, yeah, sure, I'll help out whoever, right? So we're gonna say it's possible that the evaluation of self-reported willingness to offer support to a hypothetical other might underestimate differences in actual provision of support. I don't know, it's a hypothesis, but I'm just trying to provide some context around what we found. The effects that I found very subtle, very slight. If I would have ran this in between subjects tests, I probably wouldn't have found it, right? But within subjects, we are seeing a tendency towards being more willing to provide support to trauma versus non-trauma survivors, which is kind of good. You might say, does it really have any sort of meaningful impact? I don't know, but my methods are the best I could do with what I had at the moment, but there is a strong possibility that the methods that I have here are underestimating or overestimating what people's actual behavior would be in these situations. And so just wanted to say, take this with a grain of salt. So people see how I'm kind of taking this and trying to pull all this together. Now I don't expect you to have sort of the ins and outs and have thought carefully about the whole, but like taking stuff like this in to sort of provide context. So it's not just yes or no decisions, effects or not type of things when we're going through and working with these types of analyses, particularly really powerful tests like these repeated measures designs. You're going to be able to ferret out like really rather small effects, right? And just thinking about practical implications, both in terms of the absolute magnitude effects, plus within the context of what you've actually done. Questions about what we did with just these one-way designs? Feeling okay? Okay, does this kind of illustrate though that this is only one way out of an infinite number of ways that I could have gone through and approached this? Someone else with a different hypothesis could have made different types of comparisons, but so what I'm in this hypothetical situation, like here's the reason I did it. I want to look at trauma versus non-trauma. That's the whole reason I put it together. So whether or not this is different than this is different than this, and that's different than that, is just going to be a whole lot, right? I can do it just because we can do something doesn't mean we should, or it's a good reason to. So just want to be very careful in terms of thinking about how we're strategizing your follow-up tests. Questions? Awesome. Okay, cool. So those are our one-way designs, okay? And those are fine. But a lot of the time, particularly with the types of analyses and the types of questions that we have, more often what's going to happen is we'll have this repeated measures component to our tests, but we also want to look at sort of a grouping factor, right? And with this, now all of a sudden we've got a mixed factors design. We're looking at both a between groups factor and with a within groups factor and try to combine these two together to understand a couple of different things, right? Let's say with our our simplest form of our mixed factor repeated measure ANOVA is going to be an A times B repeated measures design where I have a grouping factor, between group factor A and within the group factor on B, and looking at the interaction of these two, okay? And if I were to do that, the questions that I can ask with this are, do scores differ across levels of factor A, collapsing across repeated assessments? What type of effect am I talking about here? And again, if we take a look at this table here, just to kind of help put some numbers to stuff, let's say I have in this here, I've got a 3x4 mixed factorial design, right? I've got 3 groups, condition 1, 2, 3, and then I have 4 repeated assessments, 1, 2, 3, 4. Okay. If I'm looking at, if I'm asking, do scores differ across levels of factor A, my grouping factor, collapsing across my repeated assessments? What am I asking there?
Within subjects,
What's that?
like within subjects.
Okay, so I'm saying levels of factor A, if we're saying levels of factor A is my grouping level, collapsing across my repeated assessments. Is that a within or a between? It's my between, right? What I'm asking here is I'm looking at here, this is my main effect of my between group factor. Saying if I collapse across, if I average across all of my repeated measures, am I seeing group level differences across group 1, group 2, group 3? Okay, so if we look at this, here we got within, here's all our individual scores, right? But here we've got first assessment, second, third, and fourth. And then here's my participant average across those repeated assessments. And then here for my group is my average for this group at time 1, this group at time 2, this group at time 3, here's this group at time, same group at time 4. And then here's my overall average across things for all people here, right? Same thing going down here. If I'm asking for my main effect of group, I'm saying, does this value differ from this value, differ from this value? Collapsing across my repeated assessments, am I seeing overall group differences collapsing across my repeated assessment? People kind of see where this is coming from. You're still frowning a little bit, which is good because that suggests to me like this is tricky to wrap your head around.
I think I'm just getting confused by like what factor A and what factor B.
Okay, factor A is going to be our grouping factor.
Okay,
Factor B is going to be our repeated measure.
okay,
Okay, so let's say I'm going through and I have condition 1, condition 2, condition 3, right? And these are people who I've given different, like, let's say I've like sort of primed group 1, group 1 is my baseline. Group 2, I've primed for positive affect, and group 3, I've primed for negative affect, right? So this group, I brought them in, like, oh, hey, here you go. Do you want something to drink? Here's a snack, something like that. Group 3, I was 5 minutes late and trying to kind of treat people like garbage, right? So I kind of prime a mood, and these are just sort of regular people who come in and do stuff. So these are my different groups. I've primed these different groups to respond differently. And then here I've got task 1, task 2, task 3, task 4, and just ask them, how much do you enjoy these tasks or something like that, okay? People following me on this sort of hypothetical design, okay? What I would be doing if I'm asking if there are differences across levels of factor A collapsing across repeated assessments, basically I'm just averaging across sort of the different trials in terms of their sort of enjoyment across this and just saying, are there overall differences in my different priming conditions collapsing across my repeated assessment? This is just a straight up between groups design, right? We're just getting my output here for my between. This is just functionally, this is just a one-way ANOVA, right? I'm just looking at like, do I see mean level differences across these groups? It's just my output is just the average score across those repeated assessments, okay? These designs get really heady. Are people sort of comfortable with this in terms of thinking about what our main effect of our between group factor is looking at? Okay. Then we can also ask, do scores vary across repeated assessments of factor B collapsing across group? What is this factor looking at? Main effector within, beautiful, exactly. I'm going to ignore group. I don't care whether or not you're in what priming group you're in. I'm just looking at, if we look down here, our means for repeated measures. Am I seeing variability across these repeated assessments? Do I have an effective task, right? Do people's ratings of enjoyment depend on what task that they've got? I'm ignoring grouping factor, collapsing across that. This is just my main effector of my repeated assessment. Do I see differences across assessments here? And so if these are different tasks doing different types of things, right? Like maybe it's I don't know, maybe I'm a individual differences person or something like that. And these are different, or an IO person. Maybe I got like different work conditions or something like that I'm having people do. Regardless of whether or not people come in just neutral, sort of upset or happy, do I see differences across these tasks that I'm having them do? Comfortable with this? Okay. And then the last, do my repeated measures scores vary as a function of group? What am I asking here? What are we essentially teasing out with this?
interaction.
The interaction, exactly. This is my between by within interaction. Does my pattern of repeated scores of my repeated assessments does that pattern differ for one group versus another group? Okay, so here we've got a main effect of my between subjects factor, main effect of my within groups factor, and then here is my between by within. And so I'm thinking about how we go through and tease this apart, because again, this starts to become important in calculating effect size, knowing where this variability is coming from. I've got in your handouts here this partitioning variance, the between by within subjects ANOVA. It's in your it's in the handouts. It's sort of towards the top. So make sure to go through and pull this out. But if we go through and think about how we go through and section this off, just like we did before, sum of squares total is all the variability in all of our set, in our entire set, right? Here, my sum of squares total is just the sum of the squared deviations of all individual scores from the grand mean. So if I take that score minus the grand mean, this one minus grand mean, this one minus grand mean, so on and so forth, this is just all the variability in my set. Okay, but then what I'm going to do is I'm going to section this total off into my between and my within. Okay, my between is just going to be the deviation of the participant means from the grand mean. Okay, here it's going to be my participant mean here minus grand mean here minus grand mean here minus grand mean here, 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 right? This is getting just straight up between subjects differences. This is just individual difference stuff. This is sucking out all of the individual difference pieces off into this, okay? And so, but what we do here then, if I have between before, with our one-way design, we did the same thing. We pulled all the between the individual differences variance out of our model and set it over here. But could we do anything else with that in the one-way model? Nope, that was just our error term. That's just hanging out there. That's just people are different than people, right? But here, we've actually got a grouping variable. So here's all the between person differences. But what we can do is further partition that out into stuff that's due to group level differences versus stuff that's just straight up error, right? So I can go through and take a look at I can section out of my between, I can section out my sum of squares group, right? And what this is going to be is it's going to be the deviation of my group means from the grand mean. So here's the group mean for group one, group mean for group two, group mean for group three. You take that squared deviation here, squared deviation here, squared deviation here, and section out my grouping variable here. And then my subject, my sum of squares subjects within a group, this is just my between group error term, right? And I can get that easily between take my sum of squares between, subtract that, that's all that's left over, right? So what we've done here before in the one-way design, we just took individual differences and pulled them all out. What we're doing with our mixed factor design is we're taking our between group differences, we're factoring them out. But then what we're going through and we're doing is we're saying, okay, we can go through and look at this as a grouping of that variability, what's due to a grouping factor versus just sort of random stuff. Okay. You kind of see following where this is coming from. Okay. Then we have our sum of squares within. Okay. Here, what we've got is this is just going to be the deviation of our repeated measures means from the grand mean. So down here at the bottom, here's the mean collapsing across group. Here's the mean score for RM1, mean score for RM2, 3, and 4. We're just taking the sum of the squared deviations off of this, right? And this is just telling me variability that's due to differences across my repeated assessments, okay? My sum of squares cells, this is just a computational formula that we get here. And then what we'll do here, we need to get this to get my sum of squares of my repeated measure times my group. This is my third function or my third effect here. The interaction, my between by my within interaction. Here I'm taking my sum of squares cells that I created just for calculation computational purposes. And I'm taking that minus my repeated measure sum of squares minus my group measures. And the math just works out to give me that anything that's left over in this, that's not due to my repeated measures in my group, is due to the interaction effect here, okay? And then once I've got that, then I can take my within minus repeated measure minus my interaction, and I get my error term that's left over here. Okay, so the thing to think about, and the way to think about this, and again, Howell has a really nice, and it will take you a couple of times to go through and read through it, but if you're working with these designs, a really nice way to go through and think about things. Basically, with our mixed factorial design, what we're doing first off is we're just taking our between group, we're just taking a full between groups analyses, and we're just pulling it off to the side. We're just sucking all that out, and we're taking all of this and we're just hanging out and doing a bit between subjects ANOVA over here. And then what we're left with is a combination of our within stuff and our within by group, right? And again, remember that what we've done, we've pulled a full error term. Here, our between subjects now is not just error, it's stuff that we've accounted for and we've modeled by our between group factor, and then just random error. We pulled all that out, modeled it separately from my within subject stuff, making this a much, much more powerful design, okay? Now, this is kind of heady, but I think a really important thing, particularly as if you're wanting to go on and do more advanced types of modeling and sort of research and things like that, important to know kind of the nuts and bolts of this. That Bakeman article will require you to identify components and parts and pieces and parts. So eventually you'll need to go through and do this. So go through, take a look through that handout. And if you have questions, come talk to me. Also, Hal is a really great reference there to go through and see where these variance components are coming apart. Questions about this? Yeah, Danielle.
Just to reiterate what you were saying, when we're doing this, we're taking a between group analysis and we're pulling it aside and we're left with that within and then the within interaction.
Yeah.
Okay.
Yeah. And you'll see this in the output. We have a whole separate. Now, are we often sort of concerned with these designs about this piece of things? Not really, not often, but sometimes I think it's worth knowing what it is and looking at, because sometimes there can be important stuff hidden in there, right? Interesting things to be like, you know what, really doesn't matter what task in sort of our hypothetical example, you say it really doesn't matter what sort of task people are doing. What people come in at, if people are in a bad mood, doesn't matter what task they're doing, they're going to be miserable. And if they're in a good mood, they're doing okay. Or maybe if they're in a good mood or a neutral mood, it doesn't matter. It's just really the bad mood that makes a difference. Regardless, collapsing across this, we're just seeing clear differences, a huge effect of state level mood in terms of people's sort of evaluation of performance. So maybe something to attend to, right? Now, maybe we see an interaction of this stuff going on, but again, anything that you would get spit out to you in terms of SPSS, I would want you to be able to look at, know what it means. And so think about, like, is this interesting or relevant to what I'm doing? There's cool stuff that happens in there if you know what to look for. Okay. All right. So we'll go through some assumptions here, and then we'll sort of take a break with stuff. So our assumptions for our mixed factors ANOVA. So now we've taken a between subjects thing and a within subjects thing, and we've exactly, we kind of just mashed it all together, right? Fancy analyses are cool, but they also come burdened with whole bunches of lots and lots of different assumptions, okay? So our between subjects assumption, we have a normality assumption, right? But again, because we're talking about means-based designs, what's our normality assumption for ANOVA and our means-based designs?
False.
What's up?
On zero or like
distribution.
Okay, so normal distribution of what? Of my observed scores?
no,
What is it?
the population.
Close. People are whispering. Mandy?
Can we assume that the distribution is normal?
Okay, but what distribution? Not the difference scores.
Our sample?
What's up? The means.
Our sample?
There we go. What was it?
Distribution.
Distribution of my sample means. We're getting pieces and parts all over it. So we got distribution means is it. So again, remember that anytime this is really, really important, right? Because it starts to play into like what I'm going through and so what I'm picking out of my screening. I kind of ugly distributions of my observed scores. That's not necessarily problematic because my assumption of normality with on all of these is going to be normality in my distribution of sample means. Right? No matter what two conditions, my distribution of sample means become normal. Population that I'm pulling from, like whatever I'm looking at has a normal distribution of population. That's one, or what's the other one? Large sample, I got decent cell sizes, right? If either one of these two things hold, I'm gonna go through my distribution of sample means is gonna be fine. Now, if I got weird screwy stuff like hanging out there, then that starts to become, I can't just ignore it, right? But important to recognize what that normality assumption pertains to. Now, if I'm talking about regression, that's a different thing. Now I'm assuming that my SANT scores do follow a normal distribution, but here for means-based stuff, it's the distribution of sample means, that's our assumption, okay? And then for a between subjects component, I'm saying that I'm expecting to see homogeneity of variance across groups, okay? Now, we're all familiar with homogeneity of variance. We know what homogeneity of variance is. Only complicating factor is now we have not just one Levine's test, but however many repeated assessments we have, that's how many Levine's tests we have, right? So we were checking homogeneity of variance at time 1, homogeneity of variance at time 2, homogeneity of variance time 3, however many sort of repeated assessments you have, we're assuming that the variability in scores is equal across groups, across each assessment point, right? So we've got some between stuff going on there, okay? And then for our within subjects component, we have normality. Again, we're assuming normality in the distribution of my sample means, homogeneity of variance across intervals, right? So that says within our group, I'm saying that variability at time 1, time 2, time 3 is all sort of roughly equal. People remember what we're testing that with? What statistic would we use to previously did we? This is our F max, right? Remember the ratio of my largest variance to my smallest variance, okay? And then my assumption of sphericity, right? We talked about sphericity. We ever assume that we've met our assumption of sphericity? No, we just assume that we've always violated it. And so we just proceed to our greenhouse gas corrections here. Okay. So questions on our assumptions here. Okay, this is not anything different than what you've done previously last semester with your screenings. It's just more of it to handle, right? Because now what I need to do is I need to go through and test assumptions. However many cells I have, I need to test assumptions in each one of those cells. So if I've got a 2x3 design, how many cells do I have to test? Normality, outliers, things along those lines, 6, right? As these designs start to get bigger and bigger and bigger, right? There's more and more things that you have to go through and do. Now, we'll go through examples of kind of how to like stream, like I don't want to get like 15 pages of like you marching through stuff individually for each thing. So you need to do that, but in terms of summarizing and communicating, you can take some shortcuts with this, and we'll talk about how to go through and do it. But again, cool analyses, but not without costs, right? Because we've got more stuff to go through and sort of keep in mind for things. Okay. So for the examples, we're going to take the same problem sets or the same data that we worked with the one way, and we're just going to layer in a grouping factor here, right? So for our ordered means, we're going to ask, do depression scores vary over the course of 6 weeks? Inpatient hospitalization. Do overall depression scores differ across treatment program? We're going to look at treatment program as a grouping variable. And then does the pattern of depression scores vary based on treatment assignment? So here we've got a repeated assessment at 1, 2, intake 2 weeks, 3 weeks, or 4 weeks, 6 weeks. But then what we're going to say is we got 3 programs. We got program 1, program 2, program 3. Okay. So here we're going to have a 3x4 mixed factorial design. So here for our unordered means, we're going to take our vignette data. We're going to ask, does willingness to befriend vary within person across different traumatic events? What we're going to do is we're going to check this down and just look at trauma stuff to make it more manageable. So we don't have a 3x8 design. That would be a nightmare. Does overall willingness to befriend differ based on belief profiles, right? Which is our group. And then does belief profile impact the pattern of friendship rating? across different types of traumatic events. So here we've got scores for willingness to provide friendship following a motor vehicle accident, following combat deployment, following sexual assault, following a natural disaster. And then we've talked about this before, this belief profile, just general beliefs about impacts of trauma, right? We've got a negative profile, like, oh, people are crazy and broken, and they sort of are gonna sort of freak out at any point in time, right? Benevolent, which is like, hey, they're fine, so it's something that happens, people are good, they're resilient, so on and so forth. And then an interpersonal component that's kind of in the middle, that's just saying like, oh, yeah, no, I'm there and I'm supporting, I think it's fine, but like, boy, I would be hesitant to sort of develop a relationship or a working relationship with someone, because I just don't know, they might be kind of unpredictable or something like that. So we're saying that we got 3 different profiles here. So again, another 3x4 design, but this one is just gonna be using means that don't have some sort of natural order to them. Okay. All right, so what we'll do, let's take a break. Come on back at 3:40, and what we'll do is we'll jump into sort of working through some actual analysis here. Awesome. Okay.
Son of a liar. I'm gonna crash your car.
So let's go through and open up the SPSS for the beliefs rating data, and have your 3x4 mixed factors ANOVA screening for the beliefs stuff is what we'll do. So we'll just walk through a screening with this. So here we have 8 different vignette ratings and our class variable. We are not going to worry about and here we've got these labeled so that we can kind of see what they are. Remember, for this example, we're not worried about non-trauma stressors. Here, right? So I'm just going to go through, sort this to see if we have class. Yep, looks like we have 8 cases where we're missing class variable. We can't use those, include those in our analyses, right? So we're going to go through and record those, what those participant numbers are, and then we're just going to get rid of them. Okay. Go through the now class variable should be good, and then I'm going to go through and look at ratings for car accident, combat, sexual assaults, and disaster here. Okay, so I was using 8 cases. I didn't just have a profile code for those ones, and so we want to make sure what those cases were, log those, but it looks like I have full data for the rest of things. Okay, so what I'm going to do now is I'm going to go through, I'm going to go to data, split file, right? And what I'm going to go through, I'm going to hit compare groups and compare by my class variable here. Okay, paste that so that I have that in there. And then what I'm going to do, just our usual analyze descriptives. I'm going to throw in accident, combat, assault, disaster, save as standardized variables. Not being super responsive. Ask for skew, kurtosis, continue, and paste that in there. Okay.
So did you put in, you didn't put in fidelity in the right?
What's that?
We only did combat, assault, and disaster.
Combat, assault, disaster, and accident. The first one can be A. You're just looking at our four
Yes.
trauma groups.
Yeah.
Okay. So got that under control. Gonna go through and run that. And what I should see is now something along these lines. Okay, I'm just gonna throw up the handout just so we can all kind of see what's happening here. Okay. So, Lindsay, as you're looking at these descriptives, what's anything that's standing out to you in terms of sort of initial evaluation stuff?
The kurtosis is kind of big on some of them.
Okay, yeah, I've got really big kurtosis on stuff. Does our skew look great?
Not great, like some of them are kind of high, like the interpersonal friendship assault
Yeah.
is pretty high.
So we've got a lot of really, again, if our threshold is 2. And if we have a skew of 2, when we actually look at those distributions, they're very, very clearly skewed. We've got skew values of sort of exceeding 2. We've got a 3 here. So we've got very skewed, very kurtotic data here, right? But is this necessarily a concern for us? What is our normality assumption?
But there has to be normality in the population.
The sampling distribution,
yeah.
sampling distribution, right? And what might I look towards here to say, hey, so again, always remember, like, what are we measuring? We're give people a vignette about someone who's sort of going through some tough stuff and ask them, how willing are you to be friends with this person on a 0 to 8 scale? Is that are those ratings probably normally distributed in the population? No, for sure not, right? Well, what do we have going for us here that we can point to say, like, maybe we don't have a huge concern? Yeah, the cell sizes are decent, right? I've got my smallest cell is 44, my largest cell 94, right? So I'm looking at my cell size and I have an imbalance. That's something I sort of my largest cell is about is over twice the size of my smallest cell. So I've got an unbalanced design. So now all of a sudden that's going to start to kick in and make me have to think carefully about things. But I'm still going to go through, look at all my distributions. But because we're running a means-based analysis, this non-normality is notable, but I'm not necessarily going to throw my hands up or scrap the whole thing or start running 1,000 different transforms right away necessarily. Okay, so going through, taking a look at that, and making sure that as we're going through, kind of taking notes on the things that we're seeing. So what I'm going to do now is go through and sort to turn my split file off, right? And then we go to analyze, descriptives explore. And for my DVs, again, I'm going to throw in accident, combat, assault, and disaster. For my factor list, I'm going to drop in class. And then I'm going to say label cases by participant number, plots, ask for histograms, continue, go do paste. Okay. And again, if I go through and do this, it's a lot to go through and do because I've got 3 cases, 4, so I got 12 different analyses that are going to be, or 12 different sets that are going to be generated out of all of this, which is a fair amount. But again, that's just kind of the task with these analyses. So here in the handout, I kind of streamlined these again. So here we're looking at distributions of friendship rating for our motor vehicle accident, for our negative benevolent, and our interpersonal group, and then box plots. Abby, what are you seeing here with these?
Lots of negative skew.
Lots of negative skew, right? So here we've got some negative skew, we got someone hanging out a little bit away from the rest of the distribution. Negative skew here. If I look at my box plot, right? For my benevolent, my interpersonal class, my first, third, and my median, my first and my third quartile are all 8s. With anything else, because there's no variability, I have no interquartile range. My interquartile range is 0. Anything falling outside of that is asterisked. Here for my negative group, which kind of makes some sense. These are people who just kind of say negative things about trauma and hold like it's a little bit less, but we've still got some stuff going on. So we've got very clearly some ugly distributions with this. Not unexpected, but still statistically something that's noteworthy, right? And if we go down through and we take a look at the same thing for our combat, so actually sort of more, less sort of one-sided, still negatively skewed, but sort of like, it's not everybody's saying, yeah, for sure, necessarily for combat. For my assault group, looks very similar to my car accident group. For my disaster vignette, again, looks very similar to the other one, right? So as we're going through and thinking about this, do I need you to go through and tell me play by play what's going on with each one of these distributions and each one of these histograms of box plots? Probably not. It's all kind of the same thing. That's one thing though that I'm kind of excited about. If I had crazy ass skew going one way in one direction and a different way with a different direction, now all of a sudden I'm worried a little bit. Did I go through and get this started again? I think, yeah, I did. Okay. Now all of a sudden I'm going to be worried because I've got skew going in the opposite directions and that can really screw with stuff, right? But we've got some obviously non-normal distributions, but my sample size is big enough so that I can maybe reasonably expect, or my cell sizes that I can reasonably expect to see normality in the distribution of sample means, and everything's kind of trending the same way. So this is kind of a nice way to go through. Here I can go through and start to consolidate some stuff and talk about things a little bit more efficiently. Okay. Questions about what we've done at this point? Basically, it's the same thing that you did with your ANOVA screenings, it just with a whole lot more groups. Okay. All right, so we go down through. Next thing we're going to do is take a look again. You know, I'll to do this, just looking at z-scores here. So we went through and threw our split file back on, right? And then took a look at our descriptives for our z-scores. Gabe, what are you seeing? Anything sort of note here?
Yeah, they're pretty big, the minimum.
Yeah, I mean, on the upper end, sort of not much, right? But the lower end here, I've got things falling 6 standard deviations from the mean, right? That's pretty nuts, right? But what contextualizes sort of the z-score stuff here? If I have really no variability outside of anything that's not 8, am I surprised that I'm getting sort of what look like very, very concerning z-scores? No, right? Anything that's not that median value and that modal value of top of the scale, right? Anybody who's not saying, yes, 100%, I would for sure provide this person with assistance is falling down below and sort of having some stuff going on here, right? So yeah, normally these would be some very concerning sort of z-scores, but given what I've gone through and looked at so far, I'm not super surprised by any of this, okay? Other thing to think about is we run it on a 0 to 8 scale. How far down can people actually escape, right? It's kind of self-contained, right? Other thing too, if I started sort of changing scores around and bringing things in, I'm actually kind of reducing kind of the people who I'd want to actually go through and see, right? And so I could, in this situation, I mean, there's not even anything really to smooth all that much for most of these. like here I could, like, oh, I'm for this one group, for this one assessment, I'm gonna pull it all the way in, but then that's starts to feel a little bit weird, like weird cherry picking, like here. And is the difference between a 3 and a 4 really all that big of a difference in this scale? Right, so some tricky decisions that I have to be thinking about, like, do I intervene? So how would I go through and do this? Okay. So the last thing I'm gonna go through and do is I need to go through and assess, remember my variance assumptions here. So I'm gonna go to analyze. I'm gonna go to descriptive statistics, go down to descriptives. I'm gonna unmark save standardized variables because I already saved. Yeah, Johnny.
I just had a quick question about the smoothing thing,
About the what?
the smoothing.
Yeah,
If you were to smooth, so say you were going to go through and smooth,
yeah.
would you have to set like criteria for each one?
Yeah, and that's the thing, right? Like, so I've got like some cells within my design that have some people kind of falling down away from the end. But then I'm just saying like, okay, so I'm forcing everybody to kind of be up in the same, and so you start to run into sort of a tricky situation, right? Because I'm gonna, and thinking about like, could I do this? Absolutely. Does it make sense to just like arbitrarily go through things? Arbitrarily go through and start changing some cells and not others, right? And so this is one of these situations where probably smoothing doesn't probably make a lot of sense with this, because it is just, and it's not impacting everybody, it's kind of hitting individual cells with this. All right, so what I'm going to do, so to get variance assumptions, I'm going to go through back to my descriptives. I'm going to uncheck standardized variables. I'm going to go to options, and here I'm just going to go through and ask for variance. I'm going to get rid of skew and kurtosis, stuff like that. We continue, and I'm going to go paste this. But what I want to do before I do this is I want to go through and resplit my file before I request variances, because I want variances for individual cells and individual groups, not everything as a whole, right? So I'm going to go through, I'm going to run that, and this is going to give me a table now with min, max, mean, standard deviation, but now I've got a column for variance, right? This is just kind of helpful. And if I go through and I take a look at my sort of output here, what I did is I've created a table. This is just to help me organize kind of what's going on. Basically, I have my negative, benevolent, and interpersonal groups. I have vignette 1, 2, 3, 4. Okay. And then I just plugged in my variances. Okay. And what I did here is now I'm just running Fmax statistics within and between. Okay. So for here, for within my negative group, I just took my highest variance, 2.99, divided by my smallest variance, 1.046. I get an Fmax of 2.86. Okay. Same thing for benevolent. Here, Fmax for within for this condition is my largest, 1.11, divided by my smallest here gives me this. Same thing here. And then I'm looking at my Fmax across groups for each one of these vignettes. Okay. So again, thinking about me having a fairly unbalanced design, right? I got 2-to-1 difference in my largest sample cell versus my smallest cell. Do I have problems with homogeneity of variance? Maybe-ish, right? Remember when we went through.
Hey Josh, just a
Yeah.
really fast question. How did you calculate those total numbers again? You said, did you just divide the
Yep,
first?
divide the biggest by the smallest.
Okay,
So again, if a relatively balanced design, 4-to-1 ratio with N, Fmax less than 10 is probably fine. With a highly unbalanced design, F max greater than 3 is probably an issue, right? So again, like we have pretty decent tolerances. Here, am I probably too concerned with my sort of overall sort of homogeneity of variance stuff going on here? It's not perfect, but it's probably not terrible, right? I don't have anything that's looking ridiculously sort of discrepant, right? So I might notice that sort of the range of my F max statistics, but probably not anything that I need to worry about too much. Okay, now my formal Levine's test, the homogeneity of variance across, so that basically I get a Levine's test that sort of is sort of on the same thing as like, so looking at some of that stuff, right? But my within, the only way I'm getting this is my F max. Levine's will come in my actual analyses, but this is kind of what I've got going on in terms of my stuff here. Okay, so scrolling down, thinking about how do I go through it and then set this up, okay? This will not be, you cannot do this or set this up this way for all sets. Sometimes you're gonna have to kind of, if there's different stuff going on in different groups, you're gonna have to kind of break it up as you did before. But here we're kind of seeing kind of the same thing going on with different things. So we can say we've got 8 cases that have missing value for class, so we got rid of those, right? No problems with implausible values. We actually looked that closely, but it wasn't, right? So I've got a final set of 223. For my distributions here, I just kind of consolidated things. I said MVA, combat, sexual assault, disaster ratings for negative, benevolent, and interpersonal groups all demonstrate pronounced skew and elevated kurtosis. I just throw it in ranges. Like it's not necessary. It's all telling me the same story. There's not one group in here that's necessarily worse than anybody else. Everybody's an offender. Like it's all sort of not good, right? Histograms for all vignette ratings and all groups indicate prominent negative skew. Box plots identify cases below 3 and or 1.5 times the interquartile range for all groups. Max value rating of 8 identifies first, second, and third quartile for MVA assault and disaster rate vignettes of both benevolent and personal classes. I'm just sort of saying, hey, this is kind of what's happening with stuff, kind of consolidating, just saying that, yeah, my distributions are sort of messed up here. Okay. Outliers, extreme values, consistent with graphical evidence of distributions, extreme values are observed for all vignettes across all negative, benevolent, and personal groups. There's just so much going on in terms of this stuff. It doesn't make sense to identify individual cases, right? So again, this is what I'm saying. In this case, we can just go through and consolidate. This is not how I want you to do this for everything. There's some of these screenings that you're probably going to want to sort of go through and break down this group 1, 2, 3, this group 1, 2, 3. But in this case, everything's so bad, but all bad in the same way. We can go through and start to consolidate. Okay. Homogeneity of variance. Some evidence for potential violations of homogeneity across groups in response to MVA, combat, assault, and disaster vignettes, right? So we'll get those from our Levine's test when we actually go through and run stuff. F max for within group variability appears to be acceptable, right? So we're just talking about that because our Levine's test is only testing between group differences, not within. Okay, but we don't look to be too bad there. Violation of sphericity assumed given this study design. Okay, so in terms of recommendations, we want to note that we've got missing values, we've got unequal cell sizes, obvious violations of normality, and extreme values. We've got some violations of homogeneity variance and violation of my sphericity assumption, right? So basically nothing's gone right in any of this stuff, right? But what we want to do is put this into context, say. So we say initial evaluation identified 8 cases with missing values. Although a small proportion of the overall sample, systematic missingness in a given class could produce biased results, should go through and take a look, right? Like if all 8 people are negative folks that I'm missing, I start to become concerned about stuff. So always want to go through and check your records, hard copies, see if we can identify why those cases are missing, okay? Violations of normality and observed friendship ratings are not necessarily problematic for underlying assumption of the sampling distribution, given the size of the individual cells. Mean ratings, individual vignettes, also robust. to observe extreme values given the cell size and the limited rating scale, right? We've got enough people, even on our smallest scale, about 40 people. Everybody's kind of stacked up. Even if someone scores 0, it's one person in a sample of like 40. Like it's not gonna drag things too far, right? It's not like they scored -50, can really drag things out. So kind of trying to take this into context. However, concerns with the potential impact of extreme values, deviation from normality, compounded by evidence non-consistent variance and an unbalanced design. For these data, noticeably smaller variances in classes with the largest cells introduce a possible underestimation of error variability in the overall model, right? What I'm saying is my largest cells have my smallest variability. And if those are weighted more heavily in terms of calculating my overall error term, I might inadvertently underestimate the variability. If I underestimate variability, and my biggest cells have the smallest variability, then my mean squared error might be too small, and I might have statistics then that are too high, because that error term is what's going on the denominator of my F statistic. I might, with this, just based on sort of, and again, this is me serving as statistical consultant, right? I'm like, not technically not bad, but the specific configuration you've got, you might be inflating your estimates of effect based on what's going on here, right? So we say potential impact of combined violations suggests evaluation of transform friendship ratings. I'll say could be warranted. Greenhouse geyser corrected test for final model should be reported to give presumed violations of sphericity. Also recommend investigators tailor conclusion acknowledge the interpretation of transform as opposed to raw scores. So what I've done here is say, hey, transformation may be something to go through and take a look at here, right? And if I were going to run these analyses, I'd probably run my transform stuff and my untransformed stuff to see if I got any difference in there, right? We're just going to go through in the example, just run through the raw scores just because it helps with interpretation. If I go through and I transform these, now I'm talking about differences in medians and sort of raw scores or differences and things like that. When I actually ran this, that doesn't really make that much of a difference. So just to make things more straightforward, the example we'll go through is actually the raw scores, but sort of if I was recommending to this person without having gone through and actually running the analysis, would say maybe you ought to look at transform. Technically, it's not bad, but sort of the specific configuration altogether may start to compound and start to deteriorate confidence in the effects that I would get out of this analysis. People see how we're kind of just pulling this all together to sort of develop a recommendation for someone who was maybe moving forward with wanting to look at these analyses. Okay, with this, any questions? Okay, really, this is just mean-based screening that you did all of last semester. It's just more things to keep track of, right? Because we've got both between and within. All right, so let's go through then in these in this data and actually run our analysis. Okay, so what I'm going to do and switch over to your between, not the ordered means, the 3x4 repeated measures ANOVA, the belief ratings exercise. So what I'm going to do is I'm going to go to analyze, go to general linear model, go down to repeated measures. Okay. I'm going to click that. And so my factor, what did I name this factor here? Rating. Okay. It's not really a time variable, it's just because there's no order to it. But I've got 4 levels to my rating variable here. So you go through and hit define. So I'm going to look at, make sure that I'm putting this in the same, so it looks like yours. We got MBA, combat, assault, and disaster. Okay. And then my between, it's going to be my class variable. And then for this, if I had sort of control variables that I could go through and throw in covariates down here. We're not gonna get into that mess, but it's certainly something that you could do, okay? But this just goes through and sets up our model, okay? So I'm now gonna go through and select contrasts. This is gonna give me polynomial contrasts, right? So this is fine. You hit continue here. For plots, I'm gonna say I want to see class on separate lines and ratings on horizontal lines. Okay, this is gonna say on my horizontal axis, I'm gonna have vignette ratings, but I'm gonna sort of go through and model across this different classes as separate lines. I'm gonna add this in. Okay, again, SPSS gives you garbage plots, but it's at least a quick way to kind of eyeball what's happening. So I'm gonna go through and continue there. Now under estimated means, I'm gonna get my marginal means for class rating and class times rating. And I'm gonna go through and drop all of those into that box there. Okay. I'm gonna hit continue. And then for options, I'm gonna ask for descriptives, effect size, homogeneity tests. Continue there. All right. People following me? So go through, let's make sure that my data are not, let's sort these again to make sure that I'm not have a split file on. Give me a big old error. Go through and run this. So if I go through, take a look at my output here. You're going to see some important stuff to start out, right? Again, my within subjects factors, want to make sure that I know what 1 is, 2 is, 3 is, and 4 is, and make sure that these are variables that I want as my repeated assessments, okay? So I know I've got accident, combat, assault, disaster, cool, what I want. Go down through, take a look at my between subjects factors. I've got my negative group, my benevolent group, and my interpersonal group. These numbers all match up with what I had expected, so feeling good about this. Here now are my descriptive statistics, okay? Wanting to go through now, I've got a bigger table here where I've got my repeated assessments as my higher order categories and my my grouping level factors going down here, right? What you're going to want to do is be able to take back and sort of think about, like, when we get into our actual effects, be able to map those effects back onto the means that you're seeing here, right? So for example, someone tell me, Johnny, if I went through and I found a main effect for group, what means would that main effect be comparing within this table?
Can I repeat the question back to you?
Yeah, in my analysis, if I were to find a main effective group, what means in this table would be compared in that main effective group? How about this? Can someone remind me, if I found a main effective group for this analysis, what is that main effective group telling me?
There's just a difference between one of the measures and the outcome, not accounting for.
So yeah, I think you're on the right direction. So collapsing across repeated assessment, we're seeing differences in my groups. Like, just thinking about that as a straight one-way ANOVA that's just getting pulled out of here, right? And so if I say collapsing across repeated assessments, I'm seeing group level differences in my mean friendship ratings. What means would I be looking at in this table, or what means would that correspond to?
If you're looking at the friendship ones,
What's that?
about the friendship ones.
Yeah.
It'd be the means for negative, benevolent, and interpersonal,
Okay,
under like that
but
category.
we've got a lot of these means, right? So we have means for negative, negative impersonal and benevolent for MBA combat assault disaster, right? Talking about an overall, in my overall main effective group, which means what I'd be looking at.
Total mean
Yeah,
for each
right.
of those steps.
I thought it would be,
Like total mean for motor vehicle, total mean. No,
Well, you're on the right track. You're on the right track. Actually, did I just?
yeah, I think you switched them. 'cause
Yeah, I
between
just,
subjects is the-
yeah, I just messed with you all because those means actually aren't off there. Okay, sorry about that. That was a real jerk move. How about this? A repeated measure, what if I found a main effect for repeated measure? That's where I would go through and look at total. Main effect of group, that would be a different thing, right? Then I would have to go through and take for the negative, I'd have to take the combination of that mean, and that mean versus this one, this one, right? For each one of those to sort of look at my collapsing and cross repeat my measures, my group mean. Okay, sorry for asking you for information that actually isn't provided in this table. But do people see where the repeated measure, the main effect of repeated measures would go in here? Okay, cool. Good work, Josh. Throwing out big. Hey, Vic, sure, go ahead and answer your question. There's not information isn't available there. Okay, so we go down through, remember we got our multivariate tests. Do we interpret our multivariate tests? No, this is just this is kind of some old school ANOVA stuff that we're not gonna sort of fool around with here. So we're gonna ignore that piece of things. My test of sphericity, am I worried about that? Not really, right? Because I'm gonna go through and assume that I violated anyway, so not gonna spend too much time with that. Now I've got my test of within subjects effects. Am I interested in this? Yeah, okay. So here I know that the answer is on this output. What do I have evidence for effects in sort of here? What do you think, Mandy?
We have evidence for, well, we're, when we look at like the rating time class,
Yep.
we have evidence for everything except for like the lower bound.
What's that now?
We have evidence for everything except for like the lower bound section.
Okay, and so to remember that we're just looking at greenhouse guys, or these are different corrections, right? So we're just gonna go through and take a look at this, right? So I have evidence for a main effective rating scale. Okay, but would I go through and immediately interpret that main effective rating scale? No, I can't, because it's involved in an interaction, right? Now I can say collapsing across all groups that, yeah, the people are rating these vignettes differently. But really, I have an interaction there that's telling me, if I say, hey, how are people rating these vignettes? I bet, I don't know, what group are they in? I have to know that, right? And so my interaction here, my rating by class interaction, this is my between by within interaction, that's telling me that the specific pattern of means across these vignettes differs depending on what group that I'm talking about here. Does that make some sense? So essentially, the way I'm thinking about this is group membership moderates the pattern of means that we're seeing across these vignettes ratings. Okay. Now, do I know, can I look at this table and know exactly what that pattern looks like? Nope, I can't. That's where I have to dig in and start looking at stuff, right? But that's what we're seeing here. All right. Now, questions about what we're and here's our sort of partial A squared stuff there, right? Okay. Now, and again, if we're thinking about how we've gone through and pulled apart our variance components, right? Remember, we got our total, and then we got between over here, I've got within, right? What are we looking at with this stuff over here? This is our what we're within stuff, right? So I have my repeated measure, my repeated measure by group interaction. And then I have my we'll call it within error. Howell's notation is subjects within or subjects by time. So the thing is, and I was talking with Mandy about this, I'm gonna have you go through that Bakeman article. Bakeman article is gonna be a bit of a puzzle. The puzzle with Bakeman is trying to figure out how his notation maps onto the stuff that we've talked about. But if you're good in terms of sort of understanding where these components are coming from, first thing I would do, I would read that paper, sort of get the general gist of things. And then I would work back through with the handout that I gave you in the slides and sort of like, okay, what are the components he's talking about? Where do these go? Once you have the notation figured out, then it's pretty much easy. Then it's just basic algebra, right? But you got to go through and know where these components are coming from. So here, Danielle, where am I seeing my sum of squares from my repeated measure?
Their rating greenhouse gases of a 20.8.
Yeah. Right there, so that's just my repeated measure, that my sum of squares, my variability across my repeated measure, right? And my interaction right here, right? This is my interaction, and then my error term is just getting dumped in right there, right? So just being able to go through and take your understanding where this is coming from and where things are getting split off into. All right, so if we go down through and we take a look here, within subjects contrasts. Is this meaningful? Can I interpret it for these data? Olivia, you give me a skeptical shake of the head. Why? You're exactly right. Why can't I interpret these?
Linear for rating and rating by class.
What's that now?
The linear line for the rating and the rating by class.
Yeah. Do these data have any natural order that makes any sense? No, right? And so if I went through and I reordered how I went through and dropped these in here, all of this stuff changes. I can put these in any order I like. It makes no conceptual difference. These are not interpretable, okay? So I could go through and get really excited about a cubic function I'm seeing here. It's nonsensical. It doesn't mean anything. It's just a number, right? That happens to be non-zero. It has no actual meaning. Right, so sort of being aware of thinking about what's going on with stuff like that, and just not biting on p-values to be excited about them. Okay. So this is getting all of our within stuff. Okay, if we go down through, now we're seeing our Levine's test. Okay, and here our Levine's test is just giving me between group differences in our MBA, our combat, our assault, and our disaster, right? Do I have violations of homogeneity of variance here? What do you think, Jen?
Yeah.
Yes, across each one of these. For every single vignette, I'm sort of seeing that I have very clear evidence of violations of homogeneity of variance across groups for each one of these vignette ratings, right? So that's going to start to play into thinking about how do I go through and appropriately tease things apart, right? Now what's maybe the only caveat that I think about in terms of making, before I get too freaked out about this stuff. Yeah, sample size. I got a lot of people in this sample, right? So these are probably going to be pretty sensitive tests, but it would probably be hard to ignore the fact. And even when I went through and looked at my screen, when I looked at my distribution, it looked like there were maybe less variability in ratings for my benevolent and interpersonal group relative to my negative groups, right? So this is something I'm going to have to keep in mind. Stuff. Okay.
Josh,
Yeah.
I have a very stupid question.
No, it's not stupid. What is it?
So while we look at the Levine test to see like the difference for our between group subject, like which part of this shows us the homogeneity of variance? Are we looking at like the V, how different they are?
Yeah, just like before. I mean, SPSS is now calculating Levine's based on sort of different variations. We'll just focus on the mean here. here.
Okay, so
Right.
just the mean, like
Yeah.
based on mean, and then the trend mean or just the baseline mean?
Just the mean, I
Okay,
mean,
perfect.
it doesn't really matter. I mean, they're all kind of pointing in the same direction with stuff, right? I mean, honestly, if you're making that fine grained of analyses based on sort of that Levine's test, you're probably off base anyway. Levine's is also influenced by normality, stuff like that, and obviously sample size, so it's not great. I mean, it's a tool, it's better than nothing, but it does suggest that there are differences in sort of how, in the variability of responses to these different vignettes. Okay. So going down through, the last thing we're gonna see is our test of between subjects effect. Okay. What is this, Haley, what is this component getting at?
The between subjects effect.
Yeah, this is my main effect of this is giving me my main effect of profile,
Mhm.
right? Do I see a main effect of profile here? Yeah, I do, right? And again, if I'm thinking about this, right, I'm gonna sort of section this off into group. And between error, right? And these components are, here's my group and here's my error. But I am seeing that I have a main effect of class here, right? Now, do I make a strong interpretation of this? No. Yeah, Abby?
I was gonna say maybe not, given that we saw the interaction
Yeah.
in the within subjects contrast.
Yeah. Yeah, and so same thing, this between is also sort of involved in the within, because in that interaction kind of trumps everything, right? That's probably the sort of where we need this to go. But what does this literally tell me? That I do have a between effect. Saying that if I collapse across vignettes, I'm seeing differences in willingness to provide friendship across these different profiles, right? Now, what that difference looks like kind of depends on what group, what individual assessment I'm looking at, right? Or what individual vignette I'm looking at. But overall, it's saying that, yeah, collapsing across scales, if I just took a look at the average friendship rating across all of these scales, I'm seeing differences across my groups, right? Suggesting that there's something going on with these belief profiles. Now, they're involved, this is involved in interaction, which tells me that the differences across these groups depend on which vignette we're talking about, but kind of taking note of this. So then if we go down through and we take a look, here's just sort of mean ratings here, right? So this are my mean rating of class. This is just telling me, this is giving me my marginal means for differences in friendship rating, overall friendship rating for negative, benevolent, and personal, right? Now these are marginal means. If you're going to go through and do something with this, plot this out, I would probably just encourage you to go through and actually calculate just the average. Basically, you would go on SPSS, take the average score across all profiles, and then sort of look at the differences across groups. But here's my marginal means for my ratings, right? And then here's my marginal means for my interaction. And if I look down through here, boy, what's happening with this? It's kind of an interesting effect. So again, remember that our means here are motor vehicle accident, combat, sexual assault, disaster. The eyeballing this, what does it look like that between, by, within interaction has going on with it?
Can you repeat again? Sorry.
Yeah, so we found gave a within, by, between interaction, suggesting that responses to these willingness to provide friendship across these different vignettes differs across profile, right? What is this kind of, what might I start to hypothesize is going on based on my plot here?
Seems like the
Combat.
second vignette
Yeah.
might be impacting the negative group more than the others.
Okay, yeah, it looks like, if I'm seeing like differences here, differences here, differences here, overall, I'm seeing a reduced profile for my negative group, right? And so that main effect of group is probably just, it looks like my negative group is different than the other two, and that they're just rating things, sort of being less willing to provide support to survivors, which is an interesting thing. But it looks like it's like where we're really seeing the bigger discrepancy is specifically for that second vignette. What's the second vignette? My combat folks, right? So, yeah, overall, my negative group is reporting less willingness to provide support. If we're talking about the combat vignette, then it's really a lot less, right? So hopefully we had some sort of ideas of approach and sort of hypotheses before we start jumping in, because there's a whole lot of things that I could start to go through and sort of tease apart. And if I start developing my sort of strategy right now, it's gonna be biased because I've already like basically made all possible comparisons. And so I need to address that. So hopefully before you run these, you set your hypotheses up ahead of time, right? To help things out. But people kind of see how this is working through and how we're getting this stuff. Okay, these are pretty cool designs. There's a lot of stuff going on, a lot of different nuance that we can pull out of this. It's just trying to keep everything straight in our heads. Okay. So let's go through quickly and touch on, you know what I like? I like that we're way far ahead in terms of the syllabus, that we have time to sort of go through and take a look at this. Pull up your ordered means handout. So this is our program stuff. So again, we'll move through this more quickly, just it's the exact same thing, but just to go through, talk about kind of what we're seeing here. So for our ordered means, remember we've got depression scores at baseline, 2 week, 4 week, and 6 week. Okay. And then we've got programs 1, 2, and 3. We don't know what the programs are. We're just saying that they're different programs. Okay. Got our descriptives. And I just kind of truncated this and jumped right into our test of within subjects effects. Jalen, what are we seeing in terms of our test of within subjects effects? What are we finding here?
There is a significant effect of the session, meaning like how many
Yes,
sessions they've had.
that's our repeated assessment.
And then there's also a significant interaction between the session and the program.
Exactly, right? And so again, conceptually, what I'm saying here for my session effect is saying collapsing across groups, ignoring group. If I just look at everybody, I'm seeing differences in the pattern of means across repeated assessments here, right? My session by program interaction though is saying that pattern of the pattern of means across repeated assessments, it just differs based on which program I'm talking about. Okay, so really can't emphasize enough. And when you're writing this up, I want you to be able to like give me that. Like if you see an interaction, just don't tell me there's an interaction. Tell me conceptually what that means, right? Saying here, and again, the pattern of means is not necessarily the change. It's just sort of the pattern of means we're seeing across repeated assessment differs based on what group we're talking about here. Okay. Now, if we go down through and we take a look at my within subjects contrast, could I go through and make an interpretation of these? Maybe, right? Because I've got at least within session, I have ordered means, and so my linear would make some sense. I could make an argument for the quadratic. Cubic, that's just screwy. I don't know. Like there's basically you'll get the order of polynomials will be equal to 1 less than the number of assessments that you got. So if I have 5 assessments, I'll get a 4th order polynomial. If I have 10 assessments or 10 repeated measures, I'll get a 9th order polynomial. Like this is ridiculous to even sort of think about, right? So SPSS is going to spit these out. I don't use these a whole lot for stuff, and because then particularly when we get into our interaction, then I'm not sure exactly how to tease that apart in a meaningful way, right? So just know what these are. understand that they can be useful sometimes, but there are limitations here, okay? Our Levine's test, now we've got kind of a little bit different thing here. So it looks at let's say that we randomly assign people to program, okay? I don't know that's the case, but let's say that we did. Here, Levine's test, do we have evidence for a violation of homogeneity at baseline? Nope. So everybody's coming in at the same time, we're just kind of randomly assigning people to group, let's say, okay? Do we see violations of homogeneity vary at 2 weeks, 4 weeks? No. By the time we get to 6 weeks, now again, I'm gonna take this with a grain of salt, because there's a whole bunch of people in this sample. We got a big sample, and we've got something that's 0.026, right? If I attach an S value to 0.026, is that overwhelming evidence of a violation? No, so I'm gonna take that with a grain of salt. But if I'm a clinical person and sort of knowing by the time I get to the end of treatment, kind of where people are gonna go, probably gonna have maybe differences in sort of how people are responding at the end. So this kind of makes some sense to me, or it's not shocking. But again, here I'm doing pretty good. Before we violated all sorts of assumptions in terms of stuff. Here, we're actually looking okay with things. If I go down through and I take a look at my between effects, do I have a main effect of group with this? No, I sure don't, right? So it looks like overall, if I took the mean depression score across those groups, am I seeing group level differences? No, right? But for this one, given the question, does the overall depression score across repeated assessments, is that a useful metric necessarily? Not really, right? Before in the last one, the average friendship rating across vignettes, is that a useful measure? I would argue kind of like overall, like are people jerks, or are they kind of willing in general to go through and help out, right? So there, in the previous one, I would maybe be more interested in kind of what's going on with this table. Here, I don't know, like what I'm not sure what to make of someone's average depression score across 6 weeks of inpatient treatment means, given that I'm expecting that to sort of change and be different, right? So again, going through and thinking about the extent to which you're focusing on different pieces and parts of this outcome is really going to depend on your question, depend on the design, depend on the conceptualization. So you have to kind of know, does this make sense? Should I pay attention to it? Or is this something I can kind of ignore? Yeah.
So like if you were wondering, like in your research question, whether it was like advantageous to continue on to 6 weeks, like you're thinking like maybe 4 weeks is enough of treatment, like would that be a time where it would be like a little more relevant to kind of look at this? So like if there wasn't like a significant difference between like 4 and 6 weeks, then
yeah, well, and so then that starts to get into, and I sort of actually did an inpatient paper sort of on, I don't do anything with inpatient data, but on internship I working with some people who did, so like, all right, let's play around with this, see what's going on with stuff, right? And so, but that question, Abby, sort of gets down to this, like, so if I did find an interaction or something that suggested a nonlinear, really, if this is what we're doing, this is where sort of growth modeling starts to come into play and be a better sort of approach for this. But here, if I had specific questions about, do I get additional benefit from 2 to 6 weeks in that, like, does it help to keep people hospitalized for extended periods, which was kind of the whole sort of question in the paper that we put together, then maybe you have a specific, even if you didn't find a grouping effect, but you found a main effect of time, maybe you would say, like, do we see differences here? What's the magnitude of decrease that we could expect from an additional 2 weeks of treatment, right? So again, if that was a question that you had, now all of a sudden, sort of making this, testing this might be important, right? In other cases, it might not. Like most of the cases, it probably won't be, right? So this is where just your conceptualization, your question of interest starts to come into play in developing your strategy for stuff. Okay. So again, this is kind of what our graph looks like. So again, we found evidence for a condition or a program by time effect. Is this as clear as the last? No, I mean, they're kind of all doing the same thing. That interaction could be happening, and this is the thing, right? Because it's a between by within interaction. That interaction could be due to differences here, differences here, differences here, differences here. It could be differences across these, so differences here, 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 here. There's any number of places where these differences could be sort of taking place. And again, if I go through and have to tease out all of this stuff just with no North Star on how to go through and do it, I'm gonna end up with a whole bunch of stuff that's not interpretable at all, right? So wanting to think carefully about how we go through and start to deconstruct these effects. Okay. All right, so if we go back through and think about how we're talking about these omnibus effects, right? I could say that evaluation of 3x4 mixed factor ANOVA with repeated measures on the final factor. Note this is just a nice way to go. These are complex analyses. This type of stuff is a nice way to sort of communicate to your reader exactly what's happening, like what's going on where, right? So here we're saying a 3x4 mixed factor ANOVA with repeated measures on the final factor. So it's, you're telling me a mixed factor, so I know I have between with within. You're telling me that the final factor is the repeated assessment, so I know which one that is, right? Strong support for a group by session interaction. Results suggest that reductions in depression over the course of intervention differ by treatment group. Okay. Here, results for 3x4 mixed factor ANOVA with repeated measures on the final factor. Modest evidence of a class by rating interaction, right? Within by between subjects effect, and these data suggest that differences in willingness to maintain friendship, hypothetical survivors of traumatic and non-traumatic events may depend on pre-existing beliefs regarding the impact of trauma, right? So we're just kind of going through and talking about like, what does this interaction mean conceptually? Please always start here, right? Because otherwise you just, now I'm sort of up to my eyeballs in contrasts and comparisons. And unless I have a good sense for what I'm looking for and what things should look like, it's really easy to start drowning in this stuff. Okay. All right. Okay. So yeah, here, right? I mean, I got a p-value of 0.026. It's just saying like, just be careful, right? I mean, like, I'm not trying to like talk down to my effect because it's my study and I sort of want people to care about it. But I also want to be careful in terms of sort of what I'm talking about in terms of strength of it. Would I bet the farm that if I were to replicate this, that it's going to happen again? I hope so. But I wouldn't, I would be nervous about mortgaging my house on, so this is going to come up again, right? Okay, so going through and thinking about, okay, how do I go through and take a look at my simple effects, okay? Again, our traditional approach to testing within subjects contrast, what we would do is we would use a pooled error term, right? So basically going through and pulling sort of this from my overall model. Traditionally, that's how we would go through and do this. And we would run contrast using that pooled error term for my overall test. And if I've gone through and I've run a great test and I've got a balanced design and I haven't violated assumptions, this is a nice assessment of the overall variance in my repeated measures stuff, right? But when we go through and we start violating assumptions, what can start to happen is we have unpredictable effects on whether or not is this a good representation of so my overall variability, okay? Howell recommends using our one-way repeated measure ANOVA trends analysis of paired sample t-tests at each level of my between subject factor. Again, what Howell is saying is like, yeah, if we go through like old school, like some of the books I have in my office where you've got tight experimental designs coming out of like experimental or like sort of like old school learning tradition where I've got a fully randomized design and I'm using rats that are all clones of one another and everything's kind of the same. And I've run this in a vacuum and everything turns out cool. But for neither one of these examples that we've got where we're using pre-existing groups or weird, it's like all of a sudden I've got different cell sizes. I've got weirdness in my distributions. I've got violations of homogeneity of variance. I've got violations of sphericity. I start to worry about just plugging this as my one error term and just kind of running with things, right? What Hal recommends is, so if I find this interaction, maybe what I do is I start running repeated measure, one-way repeated measure ANOVA at each one of my groups. Say, all right, do I have evidence of differences in group one across repeated assessments? Do I have evidence of differences in repeat assessment 2, group 3, right? And if I don't, then I don't have to worry about those anymore, right? And I can just focus on where I'm finding my stuff. Falling back on paired sample tests, things along those lines. It's a more conservative approach. We don't get to capitalize on the full design, but if my full design is just chock full of sort of broken sticks and violations of errors, then maybe I don't want to just be pulling from that. Okay. So looking at my between subjects effects, okay. What I can do is I can run between subjects, ANOVA, or independent sample t-tests at each level of my repeated measure, right? Remember that we've got to deal with right? We've got differences across groups, and then we've got differences within groups, and we have to count for both of each, right? For my between subjects test, I can go through, I can run one-way ANOVAs at each assessment point to look at mean differences across here, right? Or t-tests, however I want to do that, right? Nice thing is just a simple extension of my normal between subject stuff. Essentially, I've just got four different outcomes that I'm going through and taking a look at. We know how to do this. It's good. It's fine. It's sort of just an extension of stuff that you've already done. Cons are we're giving up degrees of freedom available in full analysis, less power, right? If I'm going through and I'm running contrasts individually here, again, using my between subjects error term for the overall model, I get to use more degrees of freedom, capitalize on the full design. So I'm kind of giving some stuff up here, right? Other thing I can do, I can calculate contrast specific variances and errors based on raw data in terms from the overall analyses, right? Here, I'm utilizing all information, maximizing my degrees of freedom, and I'm minimizing my error. So with this approach, but this is computationally intensive, it requires you to explain exactly what you did. And it also is sensitive to violations and things along those lines, which starts to make me worried about stuff. Okay. So my recommendation, if you want to get into, and so I don't know, Gabe talking with Sean at one time, he was running, I don't even know what he was doing, like some like, I don't know, Matt, I think this was before you were here too. I don't know, it was some like weird ass Latin square, like where all things were crossed with all like stuff that no one does anymore. To go through and sort of tease apart, like it sounded like a cool thing, but it was looking at sort of motivations or something like that, right? But there was stuff going on, and like he was going through and trying to figure out how to go through and like tease something apart in like old school methods books, and it's like, oh, if you've got this, then you need to go through. If you run into this, then it screws stuff up. So you gotta have to go see sort of this thing. So you went through, found the other source, and it's like, oh, you gotta go through and see the other thing, right? So like you get into that we see less in these days, but like old school methods, stuff like that, where people are generating contrast specific error terms for going through, and there's a whole field that I've never jumped into because it's just a lot, right? And there are advantages to doing that type of thing, but it's really complex, right? It's sort of the same thing with if you're going through and looking into like people who are big into sort of setting up contrasts and like, oh, are these orthogonal contrasts or not all orthogonal contrasts? And there are reasons to care about that stuff, right? But for most of the stuff that we're doing, right, probably just falling back on sort of our t-tests and the stuff that we've done before is probably an okay way to go through and approach things. If I wanna get fancy, I've gotta explain to my readers like what I exactly did, because if I'm reviewing a paper and someone's like, oh, I just magicked something up. I'm like, no, tell me exactly how you did that, cite some sources saying that's an okay thing to do, right? It just, I have more to explain, right? And I would argue from a philosophical standpoint, from sort of a statistical science standpoint, like if I can do things, if I can just like run some contrasts or paired sample tests with just the groups in question, and I get something that is 0.045, where I can magic up a fancy contrast that gets into some weird esoteric methods literature, and I get something that's 0.03. Technically, that might be better, but like really the difference between an evidence against the null hypotheses is not categorically different across those two, you know, so for what we'll be doing here, I'm gonna sort of recommend sort of taking a more straightforward approach. However, if within your lab, this is something that you do and your mentors are like, no, for these designs, this is the types of things we can build actual components and stuff like that. Howell goes through, talks about some cool stuff. And if you dig deep into the methods literature, there are different ways that you can go through and do things, right? But I would caution you, if you go through and you find, hey, if I do it this way, I get this effect, and I do it a simple way, and I get a completely different thing, that should probably raise some alarms for you. I mean, it should make us, you should maybe see small differences, but if it's like, right, if it takes me from 0.55 to 0.48, I don't know, like just because our science is policed on sort of that bright line 0.5 and that helps you out, certainly do that, right? Just know in your mind that it's not a different thing that you found, you just use a slightly different thing to sort of make people happy, right? But if you went from 0.065 to 0.002, there's probably something screwy with that, right? So just keeping that in mind. But with all of this stuff, these are complex designs. There's a lot of different ways to go through and approach these. We're going to take a pretty simple approach, as weird as that seems, but it's sort of just falling back on mostly t-tests and things like that. But within your field, within your labs, if there are sort of different ways to approach this, cool. So long as you know what you're doing and why you're doing it, you could defend it in a paper or at a conference or a presentation or something like that, you're good to go. Okay, so just wanting you to know that there's lots of different ways to go through. We're going to take a kind of a simple approach. My biggest recommendation is going to be just have a good reason for doing what you're doing. Know conceptually why we're running the tests that we're running and sort of build things from there. Awesome. All right, folks, thank you. We'll go through, we'll finish up, easily finish up next class, working through for these two problems, how we might start to tease out and sort of look into these specific interaction effects. And so we'll do that and then probably jump into ANOVA with the next thing. So, awesome. All right, everyone. Thank you.